Hi, my name's Ben Littlewood. I'm one of the applications engineers here at Transtherm. I work in the data centre industry, and today I'd like to talk to you about a recent project that I've been working on with an Adiabatic unit and 2 pump sets. This here is the Adiabatic unit, and due to the space constraints on the project, we put it onto one of our biggest units. This unit here is about 3 metres wide and 3 metres tall, but it meant that we could shorten the length of the unit in order to be able to fit within the space required. As it's an adiabatic cooler, it typically only operates in a wet mode for about 3 to 5% of the year. The remainder of the year it will operate in dry mode. These nozzles here will mist water into the air through the hottest portions of the year, pre-cooling it, meaning that we can hit the temperatures required year-round. This cooler uses our overcooling prevention system. As you can see here, this is a 3-way diverting valve. So it means that over the coldest portions of the year, where we might be getting too much cooling, we can bypass as much flow as needed in order to regulate the temperature in the data hall. The controls for this unit are supplied on a separate stand. This is due to the space constraints previously mentioned. This here is the controls both for the fan and the adiabatic system, and this talks to the BMS to supply any signals that are required. We also here have the adiabatic wet box. This has a number of filters, valves, pump and UV treatment. The UV treatment is one of a number of factors that makes us low risk for Legionellas. If you want to find out more about how our adiabatic systems work and the factors that increase this, there's a link here. This here is one of 2 identical pump sets for this system. A number of these parts are common within our range, such as the Y strainer, which we include with all of our pumps. This ensures that there isn't any sediment built up in the system. We've also added a number of extras for this, such as these isolation valves here, which can be used to isolate the flow for each component, making maintenance as easy as possible. This here is the dosing pot for the system. As it's a sealed system, this is a key component. It means that we can top up with water and glycol as needed. Under normal operation, both pumps will be operating at half capacity. This means that we can operate them under the best efficiency. However, with the redundancy capabilities, it means that if one pump were to fail for any reason, then there is no loss throughout the system. Each pump set has a 100-litre expansion vessel. This is key for sealed systems, as it means that any temperature variation which will cause a difference in pressure can be accounted for. Inside here, each pump set has a vacuum degasser. This is mainly used upon initial filling of the system, and it means that we can get rid of any air throughout the system as efficiently and quickly as possible. This is used to reduce wear throughout the system at this point, as it means that any air within the water can be quickly dispersed. Thank you for watching. I'm Ben Littlewood from Transtherm.